Now I will talk about the common aberrations and their correction. The first common aberration is chromatic aberrations. Chromatic aberrations can occur due to the physical properties of the used objective, misalignment in the microscopy setup, or a mixture of both. Most of the time, it is a mixture of both. Chromatic aberrations produce misalignments and other distortion between different channels in a microscope image. As a result, a multi-channel different color image is blurred and misaligned. There are two types of chromatic aberrations: longitudinal and lateral aberrations. For longitudinal chromatic aberrations, depending on where the image is being viewed, some of the color channels would be blurred compared to the others. On the other hand, for lateral chromatic aberrations, the image usually appears to have global scaling differences. The picture on the top over here shows how the color channels would be seen when there's longitudinal chromatic aberrations. And the picture on the bottom shows the color channels that will be seen when there's lateral chromatic aberrations. To correct chromatic aberrations, achromatic lenses are used. It contains two different kinds of glasses. The principle behind it is that it combines the lens thickness, curvatures, refractive index, and dispersion such that it leads two of the wavelength groups, red and blue, to a common focal plane. This helps to reduce chromatic aberration. However, it only mainly reduces longitudinal chromatic aberration. As such, another lens called apochromatic lenses is used. When producing the lens, fluorospar is added into the glass formulation. As a result, three colors, red, blue, and green, are placed into a single focal point, causing the chromatic aberrations to be insignificant. Another common aberration is astigmatism aberration. Astigmatism aberrations are caused by the off-axis image of a specimen point that causes it to appear as a line or a clip instead of a point. As you can see in this diagram, when it is in focus, it appears as a single point. When it is under focusing or over focusing, it appears as a round spot. And when it has astigmatism, in this case, it appears as an elliptical spot. If you look at the picture down here, an image with astigmatism appears more blurry than an image without it. The line image may be positioned in one of the two different directions, tangentially or sagittally, depending on the angle of the off-axis. These two directions will have a different configuration. As a result, they will result in different focal length. This difference in focal length is a measure of astigmatism. To correct astigmatism, an anamorphic lens that have different power in two perpendicular planes is used.